Okay, welcome to the NUPOC Video Study Guide number 31. Let's look at question 6 in the Graphing Math section of Guide 1. So we're going to go ahead and graph this third order polynomial here. So let's start by finding its roots and critical points and all that good stuff, which will give us a good description of what the curve looks like in different areas, and then we can put it over on this graph over here. So let's start by factoring out a couple of x's. We see that we can have an x, let's say y equals x, and we can pull out another x, and then we're left with an x minus 1. So we know that we have roots of x equals 0, it's a double root, and x equals 1. Alright, so we're going to cross the x-axis here at 0, and then somewhere over here at 1. Now let's take a look at any critical points that we may have here. You know, it's a third order polynomial, so we expect that it's going to wiggle a little bit. So let's go ahead and take dy dx, right? And that'll equal 3x squared minus 2x. And let's find the roots of this polynomial now. So we can pull out an x, obviously, and we're left with 3x minus 2. So either x is 0 or 3x minus 2 is 0. So that means our critical points, right, are x equals 0, which is going to be the same as one of our roots. So we're going to have a minima or a maxima there. So we'll probably just barely touch the axis, either from the top or from the bottom. And we also have another critical point. Here, if we said 3x minus 2 equals 0, we just bring the 2 to the other side and divide by 3. So we have another critical point at x equals 2/3. Okay, so let's go ahead and see what the slope is around these critical points so we can see whether we have minima or maxima. So for that, let's take dy dx, and let's evaluate left of the leftmost critical point. So let's evaluate it at, say, x equals minus 1. That'll give us minus 1 times, this is 3 times minus 1, that'd be minus 3 minus 2. Minus 1 times minus 5 would be 5, which is positive. So if we have this is x equals 0, and this is our other critical point, x equals 2/3, we have positive slope here. Okay? I'll just draw in some boundaries here, right? Positive slope to the left of our first critical point. Now let's take a look at dy dx evaluated in between these two, so let's say somewhere around x equals 1/2. So that's just going to be 1/2, 3/2 minus 4/2 equals, this is going to be minus 1/2 times 1/2 will be minus 1/4. So it won't be quite as steep, but it'll be negative in that region there. Now let's take a look at dy dx evaluated to the right of the rightmost critical point. So somewhere over here, so let's just say x equals 1, right? Which would be 1, and then 3 times 1 is just 3 minus 2, 1 times 1 equals 1, right? So it'll be positive again here. So looks like x equals 0 is a maxima, x equals 2/3 is a minima. So, and right here, this is a maxima and it's a root, so it looks like we're going to come up and barely kind of brush the x-axis here. Okay, and let's go ahead and evaluate now what we know what the value of the function is going to be at this critical point, because we know it's a root, so we know it's just going to barely brush, just barely let the x-axis know that it's there. And but at x equals 2/3, we got to know, is this going to be way down here? Is it going to be close? We know it's probably going to be close because these critical points aren't too far apart, and it doesn't seem like the slope is too steep there, so let's check it out. So let's evaluate, excuse me, not dy dx, let's evaluate the function y at the critical point 2/3, right? So that'll just be 2/3 cubed minus 2/3 squared. 2/3 cubed is going to be 8 over 27. Squared is going to be 4 over 9. Let's use 81 as our common denominator. 81, so this is going to be multiplied by 3, so it'll be 24 81sts, minus this has to be multiplied by 9, so 36 81sts is going to equal minus 12 81sts. Okay. Now if you're following along with the solution manual, you notice that this is not what the solution manual gets, and I've gone over this multiple times and with other people, and it seems that I believe the manual might be incorrect on this one. They list minus 28 81sts as the value of the function at the point x equals 2/3. But anyways, so just a word of caution if you're using the solution manual here. So let's go ahead and graph this. So we have pretty much everything we need to know. We could go and look at the second derivative, but since we know what all these slopes are, we can go ahead and graph it. And then we'll do the second derivative in a minute. So it looks like we're positive here, and we're coming up to just barely lightly touch the x-axis here. So we're going to come up something like this, right? Barely touch it. Okay. And then we know we have to cross the x-axis again at x equals 1, and it doesn't look like we're doing much after that. So let's just say this is x equals 1 way out here. That makes this probably x equals 2/3, and that probably makes this x equals 1/3. 1/3, excuse me. So we got our critical point here, and it's at minus 12 81st. That's pretty darn close to, that's pretty small, so I don't know. Let's exaggerate and just say it's right here or something. So we come back down and hit this critical point here, which is going to be our minima. So it's at x equals 2/3 and y equals minus 12 81st. And then we come back up right here, cross the x-axis, and head up in the positive y direction. Now if we want to know what our inflection point is in this region here, we can just take a look at d2y dx2, right? And this will give us, let's see here, where's dy dx? Okay, this is dy dx, so this will give us, what, 6x minus 2, and set that equal to 0, so we will have an inflection point, okay, at, bring this to the other side, divide by 6, and that'll be at x equals 1/3, right? So somewhere at x equals 1/3, this is where the slope changes from getting more negative to starting to get more positive. Alright, so that's just a quick walkthrough of going from this third order polynomial to finding a fairly detailed sketch of its graph.